All right, this video is over solving quadratics by factoring. So it says, in many cases, we can find the solutions or roots, zeros, x-intercepts of a quadratic equation by factoring rather than graphing. Follow the steps below to find the solutions of the given equation by factoring. So the first thing is you want to set the equation equal to 0. So where it says y equals, instead of y, you're just going to put a 0 there. So you're going to say x squared plus 3x minus 10 equals 0. Okay, then it says factor the left side. Okay, so we're talking about this side right here. We want to factor it. And remember all the different ways that we've talked about factoring. You could do basic factoring, which is with a trinomial. You can do difference of squares. You can do greatest common factor. You just have to go through which method and figure out which one it is that you need to do. Well, on this one, since it's a trinomial and there's not a number up here, it's just going to be basic factoring. So what two numbers multiply together to give you negative 10 and add to give you a positive 3? Well, that's going to be 5 and negative 2. So we have x plus 5 and x minus 2. Okay, so then after you have factored it, then you're going to set each of your factors equal to 0. So we have x plus 5 equals 0 and x minus 2 equals 0. Then you're going to solve those. So on this one, to get x by itself, we have to do the opposite operation here. So we have to subtract 5 over. So 0 minus 5 is negative 5. And on this one, to get x by itself, we have to do the opposite of subtraction, which is addition, and we have to add 2 over. And we have x equals 2. So our roots, solutions, x-intercepts, zeros, they're going to be negative 5 and 2. Okay, remember on the last note sheet, we talked about what roots are, and it's where your graph crosses the x-axis. This is doing the exact same thing. This is just solving it algebraically, solving by factoring. Okay, so the final thing is you want to write your answers in a solution set. So you just say x equals squiggle brackets, negative 5 comma 2 is our answer. Okay, so on the number 1, they already have it set equal to 0. Okay, so we just want to factor. So what multiplies to get 3 and adds to get 4 is 3 and 1. So you say x plus 3, x plus 1. Then we want to set our factors equal to 0 to solve. So x plus 3 equals 0, x plus 1 equals 0. To get x by itself here, the opposite of addition is subtraction. So we have to subtract 3 over. X equals negative 3. Over here, we've got to subtract 1 over. X equals negative 1. So our solution set is negative 3 and negative 1. These are our x-intercepts. On number 2, what multiplies to give you 24 and adds to give you 11 is 8 and 3. So x plus 8, x plus 3. Set each factor equal to 0. And then solve each of them. So we want to subtract 8 over, x equals negative 8, and subtract 3 over, x equals negative 3. Our solution set is negative 8 and negative 3. Okay, number 3, what multiplies to give you negative 2 and adds to give you a positive 1? It's going to be 2 and negative 1. So x plus 2, x minus 1. Set them equal to 0. Okay, to solve the first one, you want to subtract 2 over. So x equals negative 2. To solve the second one, you want to add 1 over. X equals a positive 1. So our solution set is negative 2 and 1. Number 4, what multiplies to give you negative 27 and adds to give you 6? It's going to be 9 and negative 3. So you say x plus 9, x minus 3. Set each of them equal to 0. To solve the first one, you want to subtract 9 over. So x equals a -9. The second one, you want to add 3 over. X equals 3. So our solution set is -9 and 3. Okay, you're just going to continue doing the same thing. Let's skip down to number 7 down here. What multiplies to give you 25 and adds to give you 10 is 5 and 5. So we have x plus 5 and x plus 5. Okay, so then you would just set each of those equal to 0. Now notice, since they're the same exact factor, you're going to get the same answer on both of them. Okay, but if you get the same answer, when we're talking about it crossing the x-axis, that means that it's only going to cross at that one point right there. You wouldn't write it twice. There's no point in writing it out twice. Okay, so we're going to subtract 5 over. So we have x equals -5 is going to be our 0, our solution, x-intercept, root, whatever you want to call it. That's going to be the answer. Okay, let's flip over to the back side. On number 9, we have a binomial here. So what method we would want to use, we have an x in both terms, so we would want to take out the greatest common factor. So we have x, and then x squared divided by x is x. -8x divided by x is -8. So those would be our two factors. So you're still setting them equal to 0. So x equals 0. Okay, you don't have to do anything else after that. Then you have x minus 8 equals 0. To get x by itself, you want to add 8 over. So we have x equals a +8. So our roots here are going to be 0 and 8. So you put it in a solution set. Okay. Number 10, we have another binomial, so greatest common factor. We can take a 3 out and we can take an x out. So 3x squared divided by 3x is x. 15x divided by 3x is 5. We want to set each of them equal to 0. So 3x equals 0. To get x by itself, you divide both sides by 3. And 0 divided by anything is 0. On the other one, we want to subtract 5 over. So we have 0 and -5 are our roots. On number 11, we can take a 6 out and we can take an x out. 6x squared divided by 6x is x. -12x divided by 6x is -2. Set the factors equal to 0. The first one, you want to divide both sides by 6. And x equals 0. This one, you want to add 2 over. And x equals 2. So our solution set is 0 and 2. Okay, on number 12, we can take a 2 out and we can take an x out. 8x squared divided by 2x is 4x. -6x divided by 2x is -3. Set them equal to 0. Okay, the first one you want to divide by 2. So if x equals 0. The next one, first we would have to add 3 over. So we have 4x equals 3. Then to get x by itself, you'd have to divide both sides by 4. So we have 3/4. So 0 and 3/4 are going to be our roots. Okay, so they don't always have to be a whole number. You could have a fraction at times as well. 13. This time we have a binomial, but we don't have a greatest common factor we can take out. So on this one, we're gonna have to do difference of squares. Remember with the difference of squares method, you just take the square root of each term. So the square root of x squared is x, and the square root of 64 is 8. So we have x plus 8 and x minus 8. And then we set each factor equal to 0 and solve. So subtract 8 over, x equals negative 8, add 8 over, x equals a positive 8. So our solution set is negative 8 and positive 8. 14, same thing, okay? We can do the difference of squares. So we have x plus 5, x minus 5. Set them equal to 0. So subtract 5 over, x equals a negative 5. Add 5 over, x equals a positive 5. Same thing, so we can do difference of squares. So the square root of 4x squared is 2x. The square root of 81 is 9. So we have 2x plus 9 and 2x minus 9. Set each of them equal to 0 and solve. So 2x plus 9 equals 0. 2x minus 9 equals 0. So on the first one, we want to subtract 9 over. So we have 2x equals negative 9. Then we want to divide by 2. So negative 9 over 2. The other one, we want to add 9 over. So 2x equals a positive 9. And then divide by 2. So we have negative 9 over 2 and a positive 9 over 2 is our solutions. Okay. 16, same thing. So the difference of squares, so square root of 9x squared is 3x. And the square root of 49 is 7. So we have 3x plus 7 and 3x minus 7. Okay, set each of them equal to 0. And then solve them. So the first one, we want to subtract 7 over. So we have 3x equals a negative 7. Then we divide by 3. The other one, we want to add 7 over. So 3x equals a positive 7, and then divide by 3. So our solution set is negative 7 over 3 and a positive 7 over 3. Okay. Down here on this next part, so it's equations that are not in standard form. So the first thing that you have to do is you have to make sure that everything is moved over to the left-hand side. So on 17, we need to subtract 21 over here. So we have x squared plus 4x minus 21 equals 0. Then we solve just like what we did on the other side. So what multiplies to give you negative 21 and adds to give you 4 is 7 and negative 3. So you have x plus 7 and x minus 3. And then you set them equal to 0 and solve. So x plus 7 equals 0, x minus 3 equals 0. Subtract 7 over. So x equals a negative 7. Add 3 over. So x equals a positive 3. So our solution set is negative 7 and a positive 3. Okay, on 18, to get the 4x over here, we need to subtract it over. So we have x squared minus 4x minus 45 equals 0. And then factor it from there. On 19, we would want to subtract the 7x over. So we have x squared. Subtracting that 7x over with the negative 5x makes that a negative 12x. Minus 64 equals 0, and then you factor it from there. If you want to continue to get the final answer, our solution set is going to be negative 4, 16. On this one up here, it was going to be negative 5 and 9. Okay, on 20, subtract the 4x over to the 10x, so it makes a negative 14x. Subtract the 1 over, so that makes that a 48. You solve it, and you're going to end up getting 6 and 8. So we have square bracket 6 and 8. On this one here, first you want to subtract, well actually, well yeah, no, we can do that. We can subtract the x squared over here, that becomes a 10x squared. And subtract the 8x over, and it becomes a negative 8x. Okay, so then from there, you're going to end up doing the greatest common factor. You want to factor out the greatest common factor out of 10 and 8 is 2. And then out of x squared and x is x. 10x squared divided by 2x is 5x. Negative 8x divided by 2x is negative 4. Okay, and then you just work from there. You would set those equal to 0 and solve. And our solutions are going to end up being 0 and 4/5. Okay, 22, you would want to subtract 9 over, so we have 16x squared minus 9 equals 0. You're going to end up doing the difference of squares with this. The square root of 16x squared is 4x. The square root of 9 is 3. So 4x plus 3 and 4x minus 3, and then set them equal to 0 and solve, and you're going to end up getting negative 3/4 and a positive 3/4. Okay, so this is solving quadratics by factoring. Remember that this gives you the same answers as what we did with the quadratic roots when you're graphing. This is just solving it algebraically. So you're finding where the parabola intersects the x-axis.